Good morning, welcome back to SAS From Scratch. Today we're busy with Chapter 7. Chapter 7 covers a bit more of the PDV, quite in depth actually. So we'll talk about that briefly because we've already covered the PDV numerous times. And then we're also going to look at the PROC FREQ and the PROC MEANS procedures, again very briefly, because the idea in this chapter is to find data issues with your PROC FREQ and PROC MEANS procedures. So starting again with the PDV, yes again, Chapter 7 in your SAS-based prep guide covers the PDV in detail. There's a nice flow chart that you can look at. There's a nice step-by-step guide to explain how the PDV steps through the data. When is error checking done? When are the variables initialized? We've covered a lot of this, but we have not done it, I believe, as in depth as Chapter 7 in the prep guide does. So again, just to reiterate, the important thing to keep in mind is that this course, these videos that I make, are complementary to the SAS-based prep guide. So it's not meant to be in isolation. You are supposed to have both at your disposal. The chapter quiz on page 126 at the end of chapter 7 is a very good way to test your knowledge and your understanding of the PDV. You will see similar questions in the actual exam. And if you do struggle with the chapter quiz, that's a good indication that you've not fully grasped the PDV yet. So what I've shown you up until this point is, I think, very useful to understand how SAS steps through the data. But what the exam is going to test you on is what is happening at any given point in the PDV. What happens before, what's the state of the PDV before an error occurs? What's the state of the PDV just after an error has occurred? What is the state of the PDV at any given time, pre or post an output statement? So there's a lot of stuff that you need to know, and a lot of it we have covered, but you have to understand the contents of Chapter 7. And that's it for me talking about the PDV, at least for the next half an hour or so. Let's move on to the next item for today. And it's not going to be a very long video for today. I think I always say this and then it ends up being at least 30 minutes, but let's see how brief we can be. So within Chapter 7, except for the PDV and talking about the automatic variables like n and error, wrapped by underscores, of course, the prep guide also talks about debugging data issues. So it looks at the PDV, it looks at debugging issues with your code, and then it also says, okay, there might be issues with your source data. Now, these won't cause necessarily an error in your program, but they can lead to unexpected results. And so there's two procs that we're going to look at today. Two more procs to add to our repertoire. And the first of that is the PROC MEANS procedure. PROC MEANS, in a nutshell, does summary statistics. It can do a lot more than that. It can do confidence intervals. I think it can do some statistical tests and a bunch of other things. But what we're going to use it for today is specifically very basic descriptive statistics. What's your mean, your min, your max, etc. But it is more involved than that. And we will see PROC MEANS again in one of the subsequent chapters. The only thing we're using it for today is to say, using very basic descriptive statistics, how can we spot errors in our data? And PROC FREQ we're going to use in a similar way. So PROC FREQ, as the name implies, looks at frequencies, so it can count, basically, is a in a nutshell way of saying what it does. However, it is also much more involved than that. It can do, besides just frequencies, it can do two-way and n-way cross tabulation tables, and a bunch of other things. I'm not a statistician by training, but it is again a much more involved procedure than what we are going to be using it for today. So it's not their primary function to be used for identifying data issues, but it's a very quick and easy way of quickly checking your data. And so the way we can do that is by knowing off the top of our heads what the normal ranges for certain measurements should be. So in my case, for example, where I work with patient data and the human body in a way, I know, for example, that the average weight of a person is between, let's say, 50 and 100 kilograms. Anything under or over that will probably query. The average height of a person is maybe around 140 centimeters to 200 centimeters, stuff like that. Average BMI might be between 20 and 30, roughly. Body temperature around 36 Celsius, I think that's about 97 Fahrenheit. And so if you, the idea is that if you look at summary stats and it shows you, oh, the minimum height in this case is 20 centimeters, you immediately know something's wrong. Or the maximum height is 600 centimeters, you also know something's wrong. I once had, just to connect with the last bullet point there, this is a true story. I once had in my source data that a patient had a body temperature reading of 63 degrees Celsius instead of 36. That's almost double what it should be. So I queried this with the data manager, and I don't know what the data manager was thinking, and apologies if you are a data manager in your job maybe. He or she basically came back to me and said, oh, well, the nurse wrote 63 on the form, so 63 is correct. And then I replied back and I said, well, if 63 is really correct, then you've got bigger issues. This means that this patient's brain has melted and run out through their nose, and you did not mark a death event for this patient. So either way, you can either go and fix the body temperature, which we know isn't 63 degrees, or you have to go and fix whether this patient died or not. So you see stuff like this all the time in your source data. Source data is really as clean as we want it to be. Even so, where I am down the line in my job, technically there would be electronic data capture tools. People would have cleaned it and looked at it, would have mapped it into a standardized format, and then I get to work with it, and you still see source data issues at times. Partly this is because of the volume and complexity sometimes of the data, but you would think that you know it would be pretty clean by the time a person like me gets it, but that's not the case. And so if you're working with raw data, and occasionally I do, and by raw data we mean like Excel files and CSV files, and you know sometimes people just log this data in something as simple as an Excel file. Maybe it's animal data, concentrations in animals, for example, and it's a small company, and so they measure these things, put it in an Excel file, and that's their data. That's what they use. That can also be extremely dirty. That could require a lot of cleaning, a lot of error checking, because the capacity for error is so much greater in something that's that close to the source. Okay, that's a good overview, I think, of how we use it to debug. So let's look at PROC MEANS first. So this is the sales text blurb that the SAS Institute provides. So the means procedure provides data summarization tools to compute descriptive statistics for variables across all observations and within groups of observations. And when we say groups of observations, we will also be talking about bi-groups at some point. So bi-groups are officially the next episode, but we can quickly put in a bi-group in something that we'll do today. And then we can see how that works as well. So the basic syntax of a PROC means is, as always, we have PROC, the name of the PROC, and we input a data set. You can put in some extra statistics in here that you would like to be output. We're not going to be bothering with that too much today because we're only going to look at the basics. And then you specify a variable or multiple variables separated by spaces and ending with a semicolon with a var statement. So for example, here we have PROC means. The data is from the cert library, and I assume this is patients, the data set. And our variable that we're doing descriptive statistics on is the age variable. So we could have put age space weight space height if we wanted to. In this case, they're only looking at age. It's going to be as simple as that today. As I've said, we'll look at these two. We'll look at means and FREQ again in a later chapter in more detail. Oh, so restless. Sorry, my dog's walking about. The next procedure we're going to be looking at is the PROC FREQ procedure. And so that is a PROC which produces one-way to n-way frequency and contingency cross-tabulation tables. That's again the sales blurb. In a nutshell, it counts stuff. And so that's what we're going to be using it for today as well, is to create a quick way of summarizing certain categorical variables. Apologies. So if we look at the syntax, again, it's very standardized. We have PROC FREQ, the name of the procedure, data equals the input data set, and then tables, whatever variables we want to tabulate. And the example is if we have, again, cert.pats, which is the patient's data set, we can tabulate gender and age. And what we'll also look at today is at least a two-way table. So we can do gender by age, for example. So that's the two procedures that we're going to look at today. I've made a custom demographics data set that we'll work with in the exercise. I'm sure you can find something similar online, just so that you have some demographics data to work with. For the moment, I think try and follow along with me for the exercise because it is pretty basic. So this is our exercise for today. So using the custom demographics data set, let's try and identify some data issues within the source data. We're going to use both the means and the FREQ procedures. We're going to look for two things. We're going to look for unusual categorical values. Now, our data set is very simple. You'll see it in a minute. It's got a subject ID. It's got sex, age, and weight. So we've got one categorical variable in the sex column, and we've got two continuous variables in the age and weight columns. And so we're looking for any unusual categorical values in the sex column, and we're looking for unusually high or low values in the continuous age and weight columns. And if you're not sure what categorical data and continuous data are, Google is your friend. Continuous data is, for example, a range of numbers between 2 points, whereas categorical data would be something like male or female, or your risk category with your insurance is 1 or 2 or 3 or 4 or 5. whereas your weight, for example, can be 80.2 and the guy next to you can be 81.5, and that's a continuous stream of numbers, and the value can fall anywhere in between. Okay, so let's get started. I've created, as I've said, a custom data set, and let's look at that data set. If we double click on it, SAS will simply open the data set for us. We have 10,000 rows in this data set. So we run from subject ID 00001 up until subject 10,000. Excuse me. And each subject has an age, a weight, and a sex associated with it. Now, you could go painstakingly by hand and review each and every single subject until you get an issue. You could even be lazy. You could quickly scroll through the first 100 subjects and then say, well, nothing here looks out of the ordinary. 100 is a little bit heavy, but it's not absolutely, incredibly unexpected. My dog's very upset today, I'm sorry. And so if you scroll through the first 100 records, nothing looks out of the ordinary here. And if you're lazy, you might say, oh, well, if there's nothing wrong with the first 100, surely I can consider this data as safe or clean as possible, and that would be a big mistake. So let's start by doing a PROC MEANS on the continuous variables. So that would be your age and your weight variables. The very first thing we need to do is just map this library, and I'm making it access read only because I don't want to accidentally overwrite the demographics dataset that I've put in here. Let's map this library and just make sure it works. It does. And so now we can refer to this demog dataset as ep7.demog. So let's bring that in. Proc means data equals ep7.demog. Run. And we know that we want two variables. We want age and we want weight. And so the reason SAS is highlighting weight as blue here is because weight is also a keyword for certain other statistical measures that we can do here with proc means. So let's run this. And SAS is going to output straight to our results table and say, okay, how many counts do we have? We have 10,000 counts for age and weight. What is our mean age? 29.9, about 30 years of age, that's fine. What's our mean weight? About 80 kilograms, that's all right. We're not going to worry too much about the standard deviation. The standard deviation says, on average, by how much does a value differ from the average value? That's also something that you can Google. And then we look at our minimum age. That's 20. That's fine. That's an adult. That's a person who can consent to taking part in this study. Our minimum weight is 60. That's fine. That's also not a problem. And then we start to look at our maximums. And now we have a problem. We should not expect to see somebody who's 290 years old. We should not expect to see somebody with a weight of 880 kilograms. So, oops, wrong button. So, what we've got here is within 10,000 records, even though the first 100 records were fine, we do have data issues that need to be queried. And we can now go and do a check. We can do a very selective check. So we can say, for example, and we can learn about the filter function as well in SAS Studio. So if we click on filter, it allows us to type something in here, filter expression, and that's very similar to your where statement. You can use all of the same, most of the same, I think, conditions and expressions and operators as you would use in your where statement. So for example, we can say, well, we know the minimum ages are fine, we know the minimum weights are fine, but maybe show me where weight is greater than, let's make it 150. And we can see that we have 3 records in our data that have extraordinary weights. This cannot be correct. We can do the same with age, and we can say, well, we certainly don't expect to see somebody who's older than 80 in our data. Here we have somebody who's 250, can't be. Somebody who's 290, 240, also impossible. And so we've now, with a quick summary stats procedure, determined that we have a problem with our maximums for age and weight. And we can then, with a where procedure, a very precise where statement or filter expression, we can isolate those and we can query them. Apologies. So that's one way that we can use it. And just to show you as well, you can combine certain queries as well. So you can say, oops, sorry, this should be an or. There's no subject that has both age greater than 80 and weight greater than 150. But let's see for where either of these two are a problem. And we have 6 of them. So we have these subject IDs that we need to go back to our vendor or whoever provided us with the source data and say, okay, look, that age isn't right, that weight isn't right, etc., etc. Now, a very useful thing that we can do with a PROC means is to also do it by a certain variable. And what do we mean by that? We mean we group by a certain variable. Now, in this case, it might be useful. I'm just going to clear this filter of this cross. It might be useful to see these statistics by 6. And so the way you would do that, again, we've used this in a PROC sort. We've used this in a PROC. There was something else we did the other day where we also used the by statement. PROC print, I think it was. And so the one thing that we've got to keep in mind is it's very simple to add a by statement, and your procs that support the by statement are always going to look something like this. However, if we run this, we are reminded again that whenever you use a by group, your dataset has to be sorted by that by group, and our dataset is not. So F comes before M alphabetically. We expect to see all the F's before the M's. So let's do that. So we're going to run a proc sort on ep7.demog. We're going to just out it as, I'm going to say demog sorted. And then don't forget, we're supposed to also replace that in here. Our input data set for PROC means is now going to be the output data set for PROC sort. And now if we run this, we should get PROC means by sex. So here is sex F, here is sex M. We still have these strange maximum values. However, this shows us another issue, which is that we have sex equals A in the data as well. And by accident, this is normally something that you would be picking up using your PROC FREQ, because this is a categorical variable. But by accident, because we've included it in our by group and we're doing it by these categorical levels, we can see that we have 3 subjects, n equals 3, where sex equals A. Now that is unexpected. That is something that needs to be queried. That might have been, this study might have been conducted in a country with a different language, and in that case maybe their abbreviation for female or male would start with the letter A, and that's something that you could go and clean up later. So you know, that you might go back to the clinic or wherever your vendor is, and they'll say, oh, okay, actually in this language of Utopia land, whatever it might be, male can be abbreviated with an A in the local language. And so then you would go and you would say, well, if sex equals A, then sex equals M, and you would proceed with your procedure, and you would go and manually clean that data. Depending on your industry, depending on how you work, you might not be allowed to do that. For example, in my role, I can't just go and change data as I see fit. I have to refer that back to the vendor. There has to be an investigation, and then the data will be cleaned by a data manager, a data programmer, and then it'll come back to me. So just a little bit of background information, but again, very useful, and it's something that we discovered quite by accident in this data. Because recall, when we left out the by group, we could see the abnormal values, but we couldn't see the abnormal categories. Now let's take a look at PROC FREQ. We've kind of already spoiled the surprise for ourselves, because we now know that there's an abnormal categorical value. I'm just going to put something in here so that it looks tidier. Let's run a PROC FREQ on. Let's see what we decide to do. So PROC FREQ data equals. I'm going to use just the source data directly. We're not going to put a by statement in here, so I'm not too worried about it being sorted. So let's do something like tables 6. And if we run that, we get a frequency procedure output with, as you might have guessed, a number of frequencies. So we've got 3 counts of sex equals A, almost 5,000 counts of sex female, and almost 5,000 counts of sex male. So it's more or less split down the middle for the demographics, and honestly, when I created this, I used a uniform distribution as well, so we would kind of assume that as well. The percentages, cumulative frequencies, etc., that's, you know, stuff that we will look at more once we have our two-way and other tables. But for now, again, this is very useful because this has given us information about our categorical value that we did not spot by glancing at the first 100 records that we had. Now we can combine this. And we can say, okay, well, I want to look at the, let's do something like this first. So let's do sex, age, and weight. Now this is fairly straightforward. You can also count almost like a sort of histogram, but in numerical format. How often does age 20, 21, 22 occur in your data? As always, here's something interesting. These are actually continuous values that we have now noticed an issue with because we can see that there's one count where age is 240, one count where age is 250, and one count where age is 290. So we're noticing these issues as we're actually looking at continuous variables. But you would not want to use the PROC FREQ really on continuous variables. You would rather use a PROC means for that. Same goes for weight. We can see, for example, how many instances of weight 71, 72, 73. This doesn't tell us much, but then we can look at weight 800, 840, and 880 and say, okay, well, that's not right. Clearly, that should be fixed. Now, something interesting that we can do is we can do a two-way table. So we can say, okay, well, give us 6 by age. And we do that with the little multiplication or asterisk sign to say, do this variable by that variable. And if we run this, we get, and I might actually just drop some of these. So you can see that the first row is just the frequency row. That's the top row. The second row is what percentage is this. Then you get like a row percentage and a column percentage, but that's a little it's a bit of a mind flood for me. So I'm going to add some options here. No row, no percent, and no col. And I just, with a slash, I can introduce some options here. Again, it's not too important for now. But the only thing I'm interested in at the moment is the frequency. And so I've dropped the percentage, the row percentage and the column percentage, all of that, and I'm only keeping the absolute count where each one occurs. So we can see again for sex A we have 3 in total. For female we have weight 250, for male we have weight 240 and 290, and then there's our absolute totals roll, and so this one and this one, they add up. If we had missing data for certain of these items, I think it might not have added up. But in this case, it does, so we've got data populated for all these subjects in all their columns. The other thing that we can do is, instead of putting in, let's say we want sex by age and we want sex by weight, the easiest way of doing that is to just add with the space the other variable in here, and SAS will produce sex by age and sex by weight when you run this FREQ statement. So we've already seen this one, table of sex by age, and here's our table of sex by weight, which needs a little bit of a scroll. Yeah, so there's our unusual weights, and this is also done by sex. So that's basically that for today. I just want to check something. Okay, no, I just wanted to make sure my camera here wasn't actually blocking the data, but it wasn't. So that's basically it for today. That about covers everything for PROC FREQ and PROC MEANS, at least to just identify data issues with. We've already said it's much more involved than that, and this is not their primary function. The thing that I normally find more useful to do is, if you're looking at age, if you're looking at weight, even if you're looking at categorical variables like sex, a histogram, just a simple histogram plot, frequency plot of the values is also extremely useful, because you'll see, especially if you've got automatic ranges on your axes, you'll see, for example, that your weight axis is going from 60 to 800, and you'll say, okay, well, there's clearly something wrong here, and then there's little spikes in the frequency. So a histogram I normally find much more useful for this. And it comes down to personal preference. To be honest, I usually, to check the data issues, I'll just run a histogram plot with ggplot in R. But it's up to you. If you've only got access to SAS, this is a quick and easy way of identifying data issues. So that's it for today. Not too big of a chapter, at least not for this episode. However, as we said at the start, you've got to go and review everything in the PDV in this chapter. Do the quiz. If you're not comfortable with the quiz, go back, watch some of the earlier videos, work through the chapter and the prep guide again, because you can lose marks on the PDV, and those marks might be the thing that makes or breaks your passing of the SAS exam. So on the next episode, it's also not a very long episode. We're going to take a look at by groups again, the way that it's being processed, and I mean it's a by statement. We've used a by statement in a PROC sort. We've used a by statement in a PROC print and a PROC means. So we've seen it before. We will combine it with the first dot and last dot keywords functions that SAS offers, and what that does is to offer us a way of identifying the first time and a last time that a certain value occurs within a certain grouping of variables, and we'll see how that's useful and what we can use that for. But that's for next time. As always, thank you very much for watching. If you've enjoyed the video, please leave a like. You're welcome to subscribe. You're welcome to leave a comment to let me know where I can improve. But until next time, cheers. Bye-bye.